says he will not eat cookies between the sessions in his kitchen. We appreciate the solidarity.
Yeah.
All right.
This
enough.
room appears to be subterranean.
Yes, we are probably underground, although I see sunlight.
Yeah, there's something wrong. Anyway, go on with the meeting.
Okay, well, it is 2:30, and I like to start on time, so we're starting on time. Welcome, everyone, to TSVWG. This is the first of two sessions, but those sessions are back-to-back, so we're going to break for drinks and then come wrap things up after that. This is the IETF Note Well. It covers the intellectual property implications of you being here, as well as our code of conduct. The very short summary is that if there are any IPR implications for anything discussed here, you are obligated to disclose that if you're aware of those IPR implications, and also you should behave like a mature adult in our conversations. I think by now you've all figured out how to use Meet Echo. Use the raise hand button there if you wish to enter the queue. If you are remote, please only engage your video and audio when you're speaking. There is a bit of latency in turning on your mic, so you want to give yourself at least about a full second. And if you're in a back and forth, by all means, just leave your mic on. Also, if you're remote, it's good idea to use headphones because of the noise cancellation properties of the tool. And if you are here in the room on the full client, be sure to mute your laptop. Also, if you've not already, please scan the QR code, which is at the entrance to the room, and as well as on the mics there, so that your presence here is logged, and we get the right size room. Okay, here's IETF 123 resources. Again, it's Wednesday. You've probably figured this out already. But if you do need technical assistance, please do report any issues you have with Meet Echo or anything else. Thank you, Marcus and Magnus, for agreeing to be our note takers. Or Magnus, in your case, thank you for being volunteered to be the note taker. If you have any drafts that you think would be of interest to this working group, please title the draft as draft-your name, draft-TSVWG, and it will appear on our radar screens, which is good. And always, we're interested in reviewers for the documents that are under consideration here. Okay, this is the agenda, which has already been bashed, and we're going to bash it a little bit in real time here. Jason got pulled away for a last-minute appointment, so instead we're going to move up. Assuming that things are more or less on schedule, we're going to move up Mohit's talk to before the break. Then we go have drinks, then we come back, and we'll dedicate the last hour or fraction thereof to our resolution of the TLS over SCTP discussion design team, and allow the group to consider what the output of that team contains. Would anyone like to bash this agenda further? Okay, this is what we're going to do then. Okay, an update on the working group status since last we met in Bangkok at IETF 122. We've not published any RFCs, but there are a total of 3 documents currently in the RFC editors. So they've passed the last gate of ISG approval. You can see what they are there. And then we have the NQP draft that is now with the ISG. Thanks for the people who worked on that, getting it to the point it is today. There are 2 documents that are currently more or less with our AD. You can see what those are. And one is, of course, authored by Gori, our AD, so it's actually with the other WIT AD, Mike Bishop. As I mentioned a moment ago, TSVWG is a heterogeneous working group with a lot of different subjects. I know many of you here for one thing in particular. You leave when you find out the agenda doesn't contain anything that you're interested in. That's fine, but we will do much, much better if you go outside your comfort zone a little bit and read a draft that maybe is not exactly in the thing you're interested in, so we get good quality documents coming out of this group. And if we all do that, then we're all going to be better off. And so there are 2 documents that are likely to go to working group last call very, very soon. Once the outstanding issues are resolved. So those in particular, either go ahead and read it now, or when you see the working group last call announcement, read it then. That's really your best shot to improve those documents. And then there are 2 other working group drafts that are not that close to last call, and at least one of them is on the agenda today.
Yep.
Is 4895 on the agenda? No. Okay. There are also some related IDs that we're actually going to talk about today. So those 2 DTLS drafts are for the following hour. Mohit's going to talk about his Pi draft again, and we were going to talk about low latency deployment, but that is fallen off the agenda. But that is a document that contains some advice and experiences related to deploying low latency tech, i.e. L4S and NQB, in a service provider environment. And ISC documents can get reviewed and commented on as well. So please take a look at that, and I'm sure Jason would be interested in whatever. Oh, you are here. Okay, let's bash again, and we're gonna go back to the original published agenda that you find on Data Tracker and on the slide. So excellent. Yeah. So Jason's
Gauri,
here, and
Gauri, want to say something?
So, Gori Fairhurst is AD. I was going to try and give some context to Jason's talk, just so people understand. It's currently an ISE submission. It could be published that way. The current document makes some recommendations. If it's making recommendations, this group should have a look at those recommendations. And that's the reasons why it's here. The future direction we can all decide. But that's the reason why it's on the agenda today.
Yeah.
And yes, and the chairs are open to input that this should be a working group document. Go ahead.
Yeah, I think the idea here is Jason gives a talk, and if we can see how the working group feels about it. If they think this is super relevant to us and they want to work on it, then basically the AD makes the decision. But right now it's in IEC. Yeah. That's what.
And to be clear, we're not going to have a call for adoption today.
Yeah.
But if we and there's not our current plan to ever issue a call for adoption. But if everyone's like, this is great, we should have this in the working group, that is input that we as chairs would absolutely consider.
Yeah, I mean the main point here is I think what Gauri would like to hear perhaps is there is at the end of the day, if it is in IEC, there is no conflict with TSVWG. I think that's the ask here. Basically, that's why we're going to talk.
All right, we actually remembered to update the milestones beforehand, so these are not all passed. So that's exciting. Obviously, milestones are very imperfect predictions, but you see the general order in which we think that we're going to achieve our objectives.
Right, I think it looks good actually.
You want to talk about the liaison statements?
I mean, this is just for information. You got a liaison statement. I think we asked them what are we supposed to do. This is informational, so I mean, just there BBF actually working on an application of L4S. That's good. So just for your information, nothing else.
Okay. In lieu of Gauri presenting on Careful Resume QLog, we're going to have his associate Nikolai do so. So Nikolai, please approach. Do you want to run the slides? Okay. Well, let me do it. Why don't we try this once I call up the. If it doesn't work, I can do it manually. But let's see if I can find it. There it is.
All right, so just a quick update on what's happening with the Careful Resume QLog draft. Doesn't seem to be working. Right, so the draft is in AD review right now. So thank you again for adopting this at last IETF. With the revision 0, we addressed some comments from Mike Hurt and from Jörg Deutschmann, among others. And with revision 1, we added a new trigger, so new event following the according change in the main Careful Resume draft. Just to quickly mention our current implementations. So we're implementing this draft in 3 implementations right now. So the original implementation was in Quiche, and now we have another implementation in Neko, which is built upon the event definitions in Quiche. So we're reusing those. And then we have the implementation in PicoQuick. And as a sort of related implementation is we have a patch for QVIS, the visualization tool that most of you know, that also shows the phase transitions. So these events that we're specifying in this draft, so to make development easier, and we would just like to mention that. And again, this draft has been very helpful in comparing these implementations and seeing that they all behave the same. So what's next for this draft? The publication is still waiting on the QLog main schema and QLog quick events draft. And if you haven't read it so far, please do read it and give us feedback and add it to your implementations.
So what do you mean by publication is awaiting the other drafts?
So I think this is probably a question that Gori can answer best.
It's okay, I can do the questions. Why is this so low? This is based on the QLog format on the QLog events. So it's normative reference to these. So there's pretty much no sense in actually doing a working group last call on this, because until those documents are done, it might change. But it's like small changes in syntax because
Okay, so
you
can keep advancing the draft, but you just can't really deliver it to you. You can't deliver it to yourself or to Mike until
the key thing being that the code reflects the latest version.
Right. Got it. Thank you. Lucas.
Hi, Lucas Pardue, QLog enthusiast and Quick co-working, well, co-chair of the Quick working group. So responsible for both authorship and working group last call of these documents. Yeah, we have a smallish queue there. We'll get onto it in the Quick working group session tomorrow. The general schema is pretty good. We're ironing out the issues in specific events related to Quick that are not related to careful resume. So I suspect the changes will be none. There could be, but ideally none. You really can't progress any further in terms of like putting this into working group last call or requesting publication, because this needs to register events in IANA registries and all sorts of stuff that just don't exist yet. We're creating the entire extensibility framework as part of that thing. This is great because it's exercising the framework and helping us spot any issues or oversights that we've made. So this is really good work. There's some other work in Mockland maybe that's doing that too. So we're just carrying on doing this. There's no blockers as far as I'm aware, just cycles for the authors to finish QLog.
Do we need to do anything as chairs regarding the QLog directorate or anything, or is this getting the eyes it needs from the QLog experts?
I'll respond and I'll let Gori jump in. I would say this has come up last time, I believe. There was an issue raised on the QLog specs about whether we could say something in those specs. The author's view is that putting that kind of detail in the specifications themselves isn't right, but that we should make it clear about our liaisons within the IETF and identifying those. We'll probably figure out a better way to make sure that happens, but we are engaged and we're always happy to do that.
Okay, so I'm sorry, so yes or no, do you have the ball on this to make sure that it gets the proper QLog review? Okay, thank you.
So I was hoping that Lucas would be the person who appoints some sort of expert reviewer for this on behalf of Quick, and it may be himself. So when it gets to working group last call, we need somebody to tell this working group that these things are okay for Quick.
That sounds a great idea. I would say it's not a formal expert, but that we would get me and Robin to probably look over these things and respond to you.
Call yourself whatever. You've spoken in front of the mic and the chairs, and we will see something happen.
Okay. Thank you, Nikolai. Next up is Greg White with numerous L4S issues. Let's see. Are your hackathon slides in the same deck?
Separate deck.
Okay, do you want to do this first?
Yes.
Okay. That may not work, in which case I'll.
Okay. It's actually the first TSV work group meeting in a long time that I haven't been doing a presentation on MQB, which is kind of nice. All right, L4S Ops. This is a draft that has been a working group draft for quite a while. Going to the next slide here. The scope of this draft is to discuss concerns about rate imbalance in networks that have a shared queue RFC 3168 bottleneck. So classic ECN bottleneck, and if you have a mix of L4S and classic congestion controlled ECN mark traffic, sharing that bottleneck, in certain cases, things don't work very well. And in particular, L4S traffic wins out and can significantly reduce the rate of classic traffic. And so this draft addresses that potential scenario, provides guidance for operators of end hosts and how to detect that this situation might exist, as well as operators of networks, what you can do in your network gear if you happen to run these types of bottlenecks, to upgrade them in different ways. Lots of suggestions in the draft on how to do that, as well as researchers to suggest tests that third parties can do to detect whether these situations exist on the internet. Status of the draft is we're intending to submit this as an informational RFC later this year. There was some discussion in earlier IETF meetings about evolution of the L4S deployment on the internet, and do we know everything that we might know in the future about this situation, and what happens if we get new information on and new mechanisms to address this potential issue. And I think the answer to that is we can always do a BIS or an update. Since the last IETF, I did add some text. There were two action items that we left that meeting with. One was to add text to the security consideration section, so that is done. And the second one is there was a to-do left in the draft from an earlier version, and it was kind of an open question to the working group. Does anyone have any text that they would like to suggest in order to close that to-do? And if not, then we're just going to delete it. And I got no input, so it's been deleted. And then the next bullet, there was a comment on the mailing list about enabling L4S in FQCODL in Linux. And it would be nice if there were some instructions on how to do that, since that does exist in the Linux kernel. I added that as an appendix in the current draft. I received an offline comment that is that really an appropriate thing to put into what will eventually become an RFC. It could be out of date at some point. So that's a question to the working group. How do you feel about putting this information, which potentially could become obsolete, in an appendix to what hopefully will become an RFC? But aside from that one question, I think we're ready for working group last call. Any questions or comments or opinions on that one statement? I see Christian in the queue.
Yes, I mean, it's not so much a comment about your specific draft, which is fine, but a comment for the TSVWG working group. What's happening here is that we are moving away, or we are trying to move away from ancient standards to something more modern. For example, we are moving away from, in this specific example, we are moving away from having the ECN bit be the equivalent of a packet loss to having the ECN bit basically provides a signal about congestion. That's something very generic. We see the same thing in the congestion control working group when moving away from old standards like Rhino or Cubic that tend to clog the buffers to new congestion control algorithms that are more friendly to real time. And over, we have this issue of, hey, your new congestion control or your new way of doing ECN is not friendly with the ancient standards. And so I think we need to have a reflection in the TSVWG working group about how do we abandon the ancient standards? How do we evolve from them? In your case, you say, hey, if people do L4S or basically react to the ECN bit as a congestion control indication instead of blindly applying it as a packet loss, then the new algorithms tend to push out the old one. I'd say that's actually a good thing. That's actually a good thing because it provides a clear motivation for the operators to move to the new way. But I might be alone in my opinion, and I'd like to see the transport working group kind of think about that and think about how we do that. How do we abandon this ancient stuff?
Yeah, that's an excellent question. Even though it's a question more broadly to the working group, a reaction from my side. We have a couple of, well, I guess first off, I do sort of agree with you that it's beneficial when the new, better technology does better. When it's competing with the older technology in terms of adoption. It doesn't come often, but I think there's been a general feeling that a degree of fairness is necessary with new technologies, and that's the kind of crux of the issue you're bringing up. The other thought is some bottlenecks do flow queuing, which really alleviates that issue. You've got a scheduler that enforces fairness. So you don't have to worry so much about fairness with the congestion control design itself. But obviously those are not universally deployed on the internet. So yeah, so I think it's a good general question for how we avoid ossification of congestion control.
Thank you.
Chris?
Hi, Chris Box from BT. So on the point of the appendix that has the instructions, I think I find it personally useful to have instructions about how to turn it on. So I've got no objection to having that there. I will say that the paragraph is very, very brief. It could do with being longer. I mean, the other thought is, would it be better to link to a web page that has instructions on all of the Q disks in which you could enable it, and it's something that can be updated over time?
That's an interesting suggestion. I looked around and I could not find a web page that had instructions.
Yes, we need to build one.
So yeah. Someone would have to create such a web page and then hope that URL is persistent, right? But yeah, that would be an alternative for sure.
Yeah. Thanks.
Yeah. If anyone is aware of a stable web page that would provide that information, I'd be happy to swap that out.
So let me just interject to say that we do have, I think the platform has changed recently, but there's a working group wiki, which might be, like if you just need something to hook, I mean, I can't fill the content, but if you need somewhere to put content that's accessible universally, that would be an option.
Okay. Well, so then it's kind of I guess this is kind of a trade-off between text in an RFC that potentially could get out of date, but won't disappear ever, versus a link to something that could be kept up to date, but also could disappear. So
I don't have any opinion about the trade-offs, but that is a resource available to you if you find it to be useful.
One other last point on related to this topic. If you didn't attend the networking research workshop yesterday, there was a talk about that relates to this actually about the interplay between classic congestion controllers and TCP prog in particular in a shared bottleneck, and some earlier work that had been presented actually at I think a MapRG session last IETF or a couple IETFs ago that pointed out that the fallback mechanisms, which are discussed in this draft, were not working in the TCP prog implementation in Linux. And then the paper yesterday at ANRW pointed out that there was actually a bug in the Linux implementation of that fallback mechanism, which has been fixed already. So if you're intending to do any experiments of this coexistence piece, please make sure you're using the latest commits from the L4S team.
Christian's back in the queue.
Christian.
No, he's not.
Okay. All right. Then we can move on to the next one then. Next slide deck. Oops. Here's have a quick update on the L4S interops. Slides will be coming up shortly. So we did have an interop that kicked off during the hackathon this time, and has continued. So it's actually still running up in the shared workspace. And
Clicker will work.
yes. A little background. So we actually have done 6 of these previously at the previous IETF meetings, always starting with the hackathon and then continuing during the meeting itself. This is the 7th of that series. In addition, Cable Labs hosts a series of interop events as well at our facility. Those are open to anyone who wishes to attend. We do have quite extensive setup in terms of networking gear already. That's your plug and play, ready to test your applications on. It's not restricted to just DOCSIS networking gear. So if other network equipment vendors want to come in and use our lab and work with the application developers who are attending, you are welcome to. And we do have facilities for both remote participation and we encourage in-person participation, but can support remote. This time, really kind of 2 sets of tests that have been going on this time. One is with Netflix and their network delivery time control congestion controller for cloud gaming. They've been doing quite a bit of experimentation with that over the last couple of IETFs. In this case, testing against a production CDN node that's running that congestion controller. With the client being a Chrome Canary build with the Netflix UI, as well as their standalone client. And then the second set of tests, and actually the bullet at the middle there says that they're planning on writing an IETF draft to describe that rate control algorithm, and we'll submit that to TSVWG. And the second set of tests revolved around UDP prog and testing some recent updates to that congestion controller, in particular a faster getting up to speed mechanism that assists when a flow is just starting up or when the congestion signals disappear because new capacities become available. Martin.
Yeah, Martin Duke, Google. So the IETF draft they're going to do is documenting their L4S congestion control.
Yes.
And when we say TCP prog, I mean, I know what the prog requirements are, but is this like a modification of Cubic that does prog stuff or something completely different?
I can't answer that question. That's certainly a good question, but I guess we'll wait and see the draft unless someone wants to come up and speak to that point. So. I see Paul Louis in the queue.
Yeah, just to answer the question, it's something different. It has some similarities, but it's different.
Okay, thanks.
There are upcoming opportunities for interops. So next one at Cable Labs will be in the October timeframe. Haven't nailed down the exact dates on that. And do plan to come back to the next IETF as well at Montreal in November. If anyone is interested in participating and wants further details, please reach out. Okay. I think that's it for me.
Thanks, Greg. Next up is Jason, who's here after all.
re-upload.
Yeah,
slides. There's sort of two parts to this. The first part is just to give a quick operational or deployment update, and then I'll talk about the ID very quickly. So since the last time I was here, we are now up to 7.5 million homes deployed. That's about 270 million devices connected. I think in about 2 weeks, we'll be at 8 million devices, or 8 million homes, excuse me. We deployed on 3 different types of home gateways, and also several modems that are customer owned and managed, or otherwise called retail devices. We've been working on lots of other things that are coming soon, including live sports streaming, latency reduction using L4S, as well as our commercial small business service, EPON, and public wireless. So a lot of work coming soon. We haven't encountered any negative issues, and the application partners have been very pleased with the performance. So all looking good. In terms of the draft itself, which is draft living good, low latency deployment, and it's currently in version 9. There are a few things in there, and really the motivation for it was, and it started a bit different initially, it was very Comcast specific at the beginning, and what I did was adapted it over time based on feedback, and it really came out of a request from other network operators and application developers that were interested in a little bit of a cheat sheet of how to quickly get started with L4S or NQB, and what some of the issues were. So, in the beginning, it's really a lot of context setting in section 1. I think, this group, it's not as interesting to, but if you're not a TSV working group attendee, it's a helpful place to start. And then I felt it was important to try to explain in section 2 that it's really the same best effort priority, because every time I would talk to people about this externally, they would initially go to, oh, it's higher priority. Oh, you're using a DSCP marking to put it a higher priority than regular internet traffic. So it's tried to address that. And then it gives, very specific, high-level recommendations for delivery infrastructure for L4S and NQB, mentions only marking, specific, latency sensitive traffic, et cetera. What you need to do with peer boundaries, around DSCP marking and ECN, header bleaching and so on. And then mentions Wi-Fi and sort of some things there. And then the other thing that I put in later in the draft was about middle boxes. I was super surprised, although I shouldn't have been, that a lot of equipment vendors came out of the woodwork as we were talking about it and saying, hey, we know there's very few applications marking already. Just install our magic middle box, and we will automatically detect from looking at all these encrypted flows who really needs low latency treatment, and we'll mark it for you. And so I try to explain all the reasons why that's a terrible idea. And that's it. Happy to take any questions if there are any. If not, it's okay too.
All right, thank you, Jason.
Thank you.
Next up will be Stuart, delivering remotely about Apple's L4S experiments. Let's see. There it is. Stuart, you have slide control.
Thank you. I learned about buffer bloat from Jim Geddes in 2010, and I started actively working on buffer bloat in 2013. And in the decade since then, we've seen an enormous number of people working on this. Let me just check. Is my voice coming through clearly?
We can hear you just fine.
Excellent, good. We've all seen lots of presentations of experimental results, which is great. But of course, this work is pointless if it never results in actual benefits for real users. And that's why I wanted to talk about this today, because a couple of weeks ago, we reached a significant milestone where normal customers running publicly available software can start to see the benefits of L4S in their daily use. And a huge amount of preparation has gone to get us to this point. We needed L4S, an accurate ECN, and TCP Prague implemented in end systems like iOS and macOS. We've been working with the Linux kernel maintainers, to get Prague and Accurate ECN into mainline kernel Linux. Same thing for Quick. And of course, the end systems doing it alone is not enough. We need the network to support it. And Jason and Comcast have been doing incredible work getting L4S deployed to normal Comcast customers. And this is currently available in the latest public beta of iOS 18.6. That will be the main release very soon. And I will give you the punchline right at the start. L4S yields roughly a doubling of responsiveness, halving of loaded latency over the already great Comcast service. So I'm going to show some results of testing that I did. Anybody else can run these tests, and I really encourage you to do that and see for yourself and report the results. If you're on Comcast, you should see the benefits. If you're an engineer working at some other ISP or mobile phone carrier and you're experimenting with L4S to see whether you want to make that leap and deploy it, then you can run these tests and prepare information for your management about the benefits this give. And I talked about the network support and the end system support. Of course, the other thing that goes hand in hand with this is we need a benchmark tool, because just claiming it's good and looking at Wireshark traces and say, look, this is better, is not a very convincing argument for people who are not familiar with reading that. So that's why we've been working in IPPM to develop the responsiveness benchmark as a complement to today's internet speed tests that always focus on throughput. We need a tool that measures response time. And I should also give a shout out to some other organizations like Ookla, who have added upload and download ping times to the Ookla speed test. So that's another tool you can use. Now, of course, the benchmarks are useful because they let us analytically compare different approaches and different ways of running the network. But those benchmarks themselves are only useful if they reflect a real-world customer benefit. So to that end, we've been working at Apple with the FaceTime team to implement an L4S enabled rate manager in FaceTime. And that is also now available in iOS 18.6 public beta. So also try that as well. On your iPhone, you can enable developer mode and you can go into the developer settings and you can explicitly force enable or force disable L4S. So give that a try, run the responsiveness test, see what the scores are, but also try doing some FaceTime calls. The L4S setting controls the sender, so you won't see the benefits, but the person watching the video will. So have a chat with a friend and turn on L4S on both ends and do a FaceTime call and see if you notice that the video seems smoother with lower conversational latency and fewer freezes and a sharper picture. Because one of the things L4S does is it allows FaceTime to safely go to higher data rates, which it wouldn't normally do in the past, because that would result in filling up queues and horrible delays. But if the network supports L4S, that now opens the door for going to higher throughput without sacrificing round trip time as a result. So in my experience, you see a big difference in the quality of FaceTime calls. But again, don't just take my word for it. I'd love people to try this out and report back what their experiences are. The same capabilities exist on macOS. And here I show some results using the built-in network quality tool, which is on every release of macOS. And that implements the methodology in the IPPM responsiveness draft. So now I just have 3 slides here. The first one is a baseline measurement. This is my Comcast business service. That is the service I pay for. I've been using this very happily for a long time. I've got a fairly typical configuration with gigabit down, but only 35 megabits up. And you can see here the results. The idle ping time is about 25 milliseconds, which is excellent. And during a saturated upload or download, that degrades to 2 or 3 times worse than that. Now, this is already a vast improvement. When I started working on this in 2013, we were seeing 2 seconds of queuing delay in the downstream direction with cable modems. So this is an enormous improvement. If you run these tests on other networks today and on some cellular carriers, you will see a second or 2 seconds of queuing delay. I'm not going to name names, but the tests are there. So I encourage people to run them themselves. I particularly encourage network operators and engineers at those companies to run the tests on your own networks and see whether the numbers are things you can be proud of. So this is just to set the context. Comcast has already been doing a great job. Now, if I specify the -F command line option to the network quality tool, I can have control just like the switch in developer settings and iOS. I can explicitly enable or disable L4S for testing. So this is with Comcast Xfinity Internet Service, the public service that Jason was just talking about, that's rolled out to 7.5 million customers. And if I run this without L4S, then the baseline ping time is still roughly 25 milliseconds, but it gets worse during saturated download or upload. And then this is the finale that I'm so happy about. It's been more than a decade of work getting to this milestone. When I use L4S, the round trip delay stays in the ballpark of 25 milliseconds. These numbers are a little bit different. Within statistical significance, those are in the ballpark of 25 milliseconds. And what this means is you can completely saturate your network upstream or downstream or both. And effectively, it behaves like an idle network. And this really blows up the myth that when the network is busy, you should expect a horrible user experience. We in this group know that's not true. You can be doing a big download or a big upload. You can be downloading an app or a software update. You can be uploading a video, and you can be completely saturating your network. And while you're doing that, other activities, just the day-to-day stuff you do on your computers and smartphones, weather forecasts, stock quotes, driving directions, checking your email, all of this stuff is just as snappy and responsive as it is when the network is idle. So I think this is huge cause for celebration because L4S has come out of the lab. We're not just seeing research results and experimental measurements. This is now in the hands of normal customers, thanks in large part to the work that Comcast has done, and I hope that will set an example for the rest of the industry. This is my last slide. To take questions.
Yes.
Christian.
Well, that's very encouraging, Stuart. I love these results. Just a clarification question. When you compare 3 versions of Comcast,
Yes.
and they differ by having L4S enabled in the network or not, and L4S enabled in the endpoint or not. Can you clarify what exactly that means?
Yes, I'll do my best. So this slide I'm showing here is the Comcast Business Internet Service. And the nature of business service is that they're conservative. They're not looking for the latest bleeding edge technology. They want solid, reliable uptime. And other things you can get with business service like a static IP address. So this configuration here is basically the stock configuration as it's been for the last couple of years. The bottleneck does not support L4S marking, and TCP Prague will recognize that it's getting packet losses, and it will basically act like Cubic. So this is the default where the end systems are able to support L4S. They're able to negotiate L4S end-to-end at the TCP or the quick layer, but the network is not doing any marking, and you get packet loss, and Prague will recognize that. Yep.
So the clarification, in this default setup, I assume that to get this result, Comcast is fielding some kind of active queue management. Do we know that?
We have Jason in the room, who's probably better positioned to answer this authoritatively than I am. To the best of my knowledge.
Yeah, I can answer it directly.
Yeah.
So first off, the commercial cable modem service referenced here does not yet support dual queue. It does support downstream and upstream AQM, which is DOCSIS Pi. And in the residential service, that does support dual queue and, of course, upstream and downstream AQM. Upstream AQM we deployed in the first few weeks of the pandemic, rushed it out there. Downstream AQM got turned on in our virtual CMTS platform at the same time that we deployed dual queue. So we had them sort of going together at the same time as part of broader, latency reducing approaches.
Yeah, so basically what we see there in this particular slide is the benefit of running AQM, which provides some isolation between different queues. Is that
well, hang on. You're asking a very subtle question there, which is important. AQM and flow queuing are separate complementary concepts. Flow queuing provides isolation between flows. AQM is a comment on how you manage each of those queues. That do you let it filter capacity and start dropping packets, or do you do something like CODL or Pi that is a bit more intelligent about when it is time to drop or mark? But there's actually a deeper thing you're touching on there, and I'm glad you brought this up. I like flow queuing, while at the same time recognizing that it is not the solution for everything, and I'll tell you why. Hopefully I can make a convincing argument. So flow queuing will insulate your flow from the bad effects of a different flow. But I want a network that will insulate my flow from the bad effects of its own capacity seeking behavior. And I touched on this a little bit at the start when I talked about FaceTime, because I just don't want my FaceTime call to be insulated from your download filling the queue. I want FaceTime to be protected against its own capacity probing behavior from building up a queue that causes horrible delays. And that, to me, is a really important thing that is often overlooked, because
I mean that's good. So basically this slide here assumes a Pi AQM without flow queuing. Is that correct?
Yes.
Okay, and the next one?
So the next one is my other cable modem, which is sitting on the shelf right next to the business service. And this is a consumer residential service with a consumer residential modem. And in this slide and the next one, on the network that supports L4S, I wanted to compare the results of using that versus not using it. So this one is the Comcast network, because I wanted to make a fair apples to apples comparison. So this is the Comcast Xfinity service. It does support L4S. It's got the low latency DOCSIS improvements. It's got all of the benefits that are available, but not L4S. and that is providing a baseline of what you get if you were to run 5-year-old iOS or Mac OS on this new Comcast service. And then the last slide is what happens when you enable the end systems to take advantage of the L4S that the network is providing. And one of the key things about the responsiveness measurements that are described in the draft in IPPM is we very deliberately don't do, I mean, there's a couple of things that I think that are bad testing methodology. One is historically, most of the internet speed tests would measure your quote ping time when the network is idle, and then say, here's the ping time, and then they would do a download, and then they do an upload separately. And that to me is completely artificial, because who cares about the ping time when you're not using your network? That's like saying how well your car performs when it's sitting on cinder blocks in your driveway with the wheels off. I want to know how the car handles when I'm actually driving it. So
yes, I mean,
so doing
we both agree.
So, gentlemen, we have a deep queue, so can we like wrap up your conversation, Christian?
Yeah.
Thank you for explaining. I was just trying to understand exactly what was the setup there, so I could replicate it. That's all.
Thank you, Martin. I hadn't noticed the queue. So the very quick thing I'll say to wrap this up is because I think this is important, and if people haven't read the draft, I want to highlight this. The responsiveness test in IPM does a saturating TCP connection with HTTP gets or puts, and then on that same connection, it inserts a small GET request. And that is kind of mimicking the behavior where you're streaming video and watching the video, and then you skip to another chapter. And that is the same TCP connection. So now you're not insulating your video against some other traffic. You're saying on this stream, if I've built up massive buffer bloat and then I try to go somewhere else, I've shot myself in the foot. So this is directly a measure of how agile and how responsive network services can be, so they're not hurting themselves, which goes beyond just being protected from other flows. So let's move on to Chris. Thank you.
Hi, Stuart. Chris Box. Thank you for sharing the data. It's really helpful to see this and to have a benchmark against which we can compare things. Regarding, so you mentioned this is implementing the responsiveness draft in IPPM. So is the version that's in beta 3, is it the same as the most recent draft in IPM, which was released at the beginning of July?
I'm going to say I believe it is. Randall Meyer and Christoph Pasch are the engineers who've actually written that code. I did not personally write that code.
Okay.
But my best understanding is, yes, it is implementing what's in the draft.
And the other thing I wanted to ask is how reproducible are these results? So are they just one-off tests, or were you running multiple times and getting similar numbers?
I ran the test several times and got similar numbers. This was, these are initial results, that's for sure. I was very excited when we finally got all the pieces in place, and the last piece we had to get in place is the client systems here are running macOS or iOS, but of course the test servers that Apple runs in our server fleet are all in Linux. So we couldn't actually do this test until the server endpoint supported L4S. And that's why we've spent the last 12 months working with the Linux kernel maintainers to get Accurate ECN and Prague to start the process of moving that off an experimental branch and getting that into mainline. Of course, there's a bit of runway before mainline Linux ends up in Red Hat Enterprise Linux version whatever sometime in the future, because operators are naturally conservative. But the wheels are slowly moving to this becoming a standard thing that every Linux server on the internet supports.
Great, thank you.
Hi, Stuart. Martin Duke, Google. So I want to clarify. So this network quality test is adding synthetic cross traffic to build the queues that L4S will then circumvent. Is that correct?
Yes, that's correct, but I try not to use the word synthetic because that makes it sound like it's an unrealistic test. What we're trying to do is simulate actual reasonable, realistic behavior.
Understood. So it actually HTTP gets, it's not just noise. That's great. So that's great. I utilized Greg's lab infrastructure with Chrome, a Chrome L4S implementation we're working on, and saw some like roughly similar numbers in terms of RTT improvement or min RTT improvement for Google search, which is very exciting. We've launched a small experiment in Chrome beta, and where we have no control over cross traffic, and unfortunately, like up to now, we haven't seen any statistical improvement, which maybe is just a fact of the amount of cross traffic we're seeing. But it's a small data set right now for multiple reasons besides the fact that it's in Chrome beta. So we're going to try it in Chrome stable and see what happens, and we hope to see see effects emerge, especially as Comcast rolls out their infrastructure. But yeah, I'm glad that your numbers kind of agree with mine, and hopefully there's enough cross traffic and enough environments that we start to see see it move the needle just for an absolutely general population set. Thanks.
So before you go for the microphone, in these measurements you've got, this is across a broad range of Chrome users just then doing their normal day-to-day web browsing. Is that right?
That's right. Well, so I was able to filter for the Comcast ASN, so like it's not
okay.
that bad, but so probably at least I believe something like 25% of that sample probably was running through an L4S capable modem, if I recall correctly. So I'm able to do some filtering, but ultimately yes, it's whatever loads happen to be going on in that environment. I'm just kind of a victim of that. So if there's only one device running and it's or only one device doing significant uplink, then like there's not going to be any effect, obviously.
Now, for these L4S testing, were you observing the impact of L4S on normal web browsing, or were you doing an additional specific test to a server that supports L4S?
These are connections to Google from Chrome.
I see.
Yeah.
So in parallel with the user's other activities, you're also doing a test to a known good L4S capable server.
It's not L4S on the downstream, but it will send ACCN. I would love to talk. I want to respect my own congestion experience code point and like not clog the queue. But I'll send you email. We'll talk about this offline, and I would love to help. I would love to share your brain on analyzing this data. Thanks.
Thanks, Martin.
Hey, Jonathan Lennox. So I had two questions. First, so does this mean that is this just in the network quality tool, or is this also now in all TCP and quick connections from these versions of macOS and iOS?
Great question. The answer is all of them, with the understanding that we have various system heuristics, because obviously we don't want to break things. So that's why in the developer setting, there are three options, which is system default or force enable, force disable. So for you doing the testing, you can force enable or force disable, because we keep getting this request from enthusiastic engineers working at some company saying, I want to show my management how good L4S is. How do I do that? So we need a way to provide a way for them to do a realistic A/B test. For normal customers, the system default will use its own heuristics to decide when to use L4S. So with that caveat noted, yes, all TCP connections, all quick connections, all FaceTime calls will try to use L4S when possible.
Cool. And the other question I had is, are you planning to discuss or document anywhere what algorithm you're using for the FaceTime? Because I'm not sure there's a lot of public stuff on ECN for real-time media, or L4S for real-time media, or are you just using a standard prog and running UDP over it?
I don't think I can promise that on behalf of Apple. If you ask what rate adaptation algorithm FaceTime uses, I don't think it has a name. It's not like you can point at some research paper and say, FaceTime is using Scream or something. It is an algorithm that iterates over time. They look at customer data, they make tweaks, they do measurements. So it is a constantly evolving thing. And if it had a name today, the next release might be slightly different. So that is something that evolves and improves over time.
Okay, thank you.
Last one, Lorenzo.
Yeah. Yes. A couple of questions. Just the sort of kernel work is that how close is that? Do you know to actually being mainlined? Is it sort of is it one of those things that's always a year away or always 6 months away, or do we see some light at the end of the tunnel for that?
I'm not the best person to answer that. I have been working with that community and trying to encourage them. And I know we are making forward progress. So I don't think it is always a year away. I think we're getting closer.
I can jump in on that. So the Linux kernel patches are, I mean, in 3 sets. One is the accurate ECN part, and that's been actually broken up into a number of smaller patch sets. That has mostly been accepted by the at 3CH side, yeah. And no, actually both sides. So the accurate ECN option on the and negotiation at the sender as well. So guess would be within a couple of months, all of that full patch series will be accepted into the kernel mainline. The next 2 chunks are TCP prog and the dual pi squared QDisk. Those, fingers crossed, will go through much more quickly because they're not as intertwined with the networking stack as the accurate ECN is.
And the other question that I had is, you mentioned heuristics, right? Sounds like, you didn't say this, but it sounds like L4S is on by default, except when the heuristics would tell you that it shouldn't be. Can you share, if not what the heuristics do, how hard it was to build them? Because, deployment on the internet-wide will probably require other platforms to implement the heuristics. And if there's some information that you can share there, that would sort of help other platforms adopt it as well.
I'll take that suggestion back. My answer is somewhat similar to the FaceTime one, which is that these are constantly evolving. In my personal opinion, I think we made a mistake in the past that our heuristics were too good, and they're a little bit too trigger happy to disable ECN and L4S. And that allowed network operators to not notice that they had firewalls. One that comes to mind is there's one network operator that has a firewall that drops all TCP SYN packets if they try to negotiate accurate ECN. They just block accurate ECN. I don't think it's because they don't like accurate ECN. They program their firewall that it would reject anything it hadn't already seen. So that would cause the heuristics to trigger, and the customers wouldn't notice any problem and they wouldn't report anything. And I think that's counterproductive. So I'm advocating for us to actually make that. Ironically, we have to make the heuristics a little bit less good, because until people notice the problems, there won't be an incentive to fix the problems. And we have to get that balance right. Obviously, we don't want to break networking for our customers, but if we make the heuristics too good, we have no progress.
Happy eyeballs all over again. Thank you.
Yep.
All right, thank you so much, Stuart. That was fascinating. It is now our mandated break time. So, and after much churn, the agenda is back to where it was, what was advertised in the data tracker. So why don't you go ahead and go get a drink, go socialize, use the facilities if you need to, and we'll be back here in 27 minutes for Mohit's FQPI discussion, and then all the SCTP you can handle.
What else that? Discussion at the end just reminded me, and we're doing EDM IAB stuff recently for vulnerability, and like trying to find examples where people tried stuff but they didn't quite work, and whether it crashed or silent failed. This might be an example when we